Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome to WebRTC Live. I'm your host, Aaron Syme, founder and CEO at WebRTC.Ventures. We're a custom design and development agency focused on building live video applications. We're here to help you take your application live. Thank you for joining us live today on YouTube, LinkedIn, and Twitch. Welcome also to any of you watching a replay of today's event. For those of you with us live, you can ask questions throughout the stream by leaving a comment in whichever platform you're viewing this. Joining me today is Michalis, co-founder and CTO of Chord FM, and we're going to talk about how Chord has built a browser-based podcasting platform, using WebRTC, and in particular, how they've tackled WebRTC congestion control issues. Thanks for joining me today, Michalis.
Hi, Aaron. Thank you for the opportunity. How are you doing?
I'm doing very well, very well. And yeah, I'm excited to have you joining me today. There was you wrote an article that I'll just put up briefly on screen here, part of it talking about demystifying buffer bloat issues in a WebRTC enabled app. And I love this opening line. You got a great hook here at the beginning that we'll get to more later. He said, we thought that putting together a WebRTC audio video app with tools to record high quality content while maintaining stability under various network conditions would be straightforward, but we were wrong. And you're not the first WebRTC developer to say something like that, for sure. And we'll get into that in more detail later. But first, I wanted to start with a little bit more about your background in WebRTC and real-time communications, because when you started Chord FM, this was not your first time building with WebRTC. So tell us a little bit more about your past experience at Grabio.
Alrighty. That's a good question. I guess kind of trying to draw a picture here of where I'm coming from and a bit of my background. I always had a kind of a big passion for the media. I'm a kind of an audiophile and a music lover. I don't play an instrument at the moment. I did used to learn the piano, but at some point, but I've left that. Anyway, that was when I was quite younger, of course. In the last decade or so, after following some education, I found myself having an opportunity working for within an environment that had dealt a lot with the media and dealt a lot with workflows that allowed users to tackle specific challenges when it comes to producing and producing in terms of recording and editing content using tech. So as you mentioned, I found myself having this opportunity. I worked for Grabio, which is a company that does a lot into this space for quite a few years, and this is where I've kind of gained a lot of my experience, and my passion grew with that a lot as well. Obviously, specifically to Grabio, they do more of on-demand, but as well as live video, and they offer various solutions out there for businesses. So you can imagine, I got basically exposed to a lot of those workflows that involved ingesting content within the platform, and as well as transcoding and kind of outputting that to other channels. So that itself was a huge exposure into kind of a massive pipeline when it comes to the media, and this allowed me to evolve and I gained a lot more interest into what's going on under the hood. Academically speaking, I come from a computing kind of background. with a bit of machine learning and distributed systems. I spent quite a bit of time in the United Kingdom, and I now am located in Amsterdam, in the Netherlands, on a mission with Chord.fm, as you mentioned.
Excellent. So yeah, there is a lot going under the hood with WebRTC, as you mentioned, and we'll get into more of that. But let's start with let's go next. Tell us a little bit more about the use case for Chord FM, and what are some of the market needs that you saw for podcasting that it addresses.
For sure. So as my interest, of course, grew within the media and tech, I'm always trying to find problems to solve. So one of the challenges that I find still exists, and I feel there's a lot of fragmentation and a variety of tools out there for creators today, is the need to, specifically for podcasters and content creators within that space, not only within the producing space, but also within the recording, I should rephrase specifically, but also repurposing and editing. And this is exactly what Chord is trying to solve. It's trying to bring within an all-in-one platform kind of a Swiss Army knife of producing, recording, collaborating with others as well, and repurposing, editing, and creating content as quickly as possible, eliminating a lot of the friction in terms of time and tooling that someone would need in order to get their content out there. So this is Chord. Of course, I could talk about other things such as other tooling that exists out there. I can tell you after a bit of research, of course, that there's quite a few tools, of course, like Hangouts and Teams, and all of those are very similar in a sense of they can be used to create content in a sense like that. However, they not always provide the quality and the bit rates and the standards that a podcaster, a video creator would be looking for. They lack of some functionality. They also lack in terms of some stability when it comes to, and we can of course deep dive into that a bit later. But yeah, I don't want to give a massive kind of intro here. This is as far as Chord, and if you have any more questions, I'll be happy to answer.
Yeah, of course. I mean, you're correct, of course, that a lot of the sort of standard meeting tools can be used for things like recording, but those tools have been optimized for a business meeting scenario. They're not optimized for broadcasting. They're not optimized for recording. When you're building a podcast, as I've certainly learned over the years working on this, you care about different things in terms of how the video and audio files are stored, and having the flexibility of how you can compose them and the quality of that. And, so there's a whole different set of elements that, a meeting tool is optimized for, that you don't care as much about if you're doing something for podcasting and vice versa, right? So using the right tool for the right job, of course, is always important. So as you started Chord, what types of technical or business challenges did you expect to encounter?
It's a good question. I think we did for sure expect some challenges when it comes to kind of having to bring this high quality content within a browser environment entirely, because this is what we do. We operate today, at least, within a browser environment. And we wanted to support this idea of to build up towards this idea of remote collaboration with bringing the best quality, the best kind of output that someone can have within such an experience. So we looked a bit around and what other tools are trying to achieve, and what some challenges might be, and solutions to similar problems. And we identified that local recording, as we may hear it as a term out there, is something that a lot are trying to kind of approach in a similar sense. And then this is the path that we took as well. So one thing that we do is trying to solve the or trying to provide this kind of content using our local recording feature and pipeline. So we did definitely see kind of that as a challenge, and we took that path, and we came across a lot of problems that we had to solve along the way. What else? Obviously, it doesn't stop there. This is the recording part, and then you kind of end up with content that can and will be edited in a sense, and we're building towards we have a roadmap and we're building towards this direction of editing. And so if you start with something and you start building that from ground up, and you kind of have this local recording functionality that allows you to do separate tracks and separate audios and videos and all of that, then you also have to think about how are you going to store these things? How are you going to manage? Do you need to do encoding, transcoding? Do you there's a few different platforms and browsers out there, and so not all of them always provide the standards in terms of let's say video encodings and audio encoding. So at the end of the day, you do have to do a lot of work there. And so a lot of the challenges as well, I think, were specifically in trying to solve, post-production workflows. I think that's kind of the gist of it. That describes my initial feeling of, oh wow, what am I getting into?
Right, exactly. Yeah, and you mentioned recording a couple of times there, and I want to get into some of the details around that in a minute, because that's always an interesting challenge in WebRTC applications. But before we dive into recording specifically, tell us a little bit more about the architecture and kind of what the media pipeline looks like for Chord.
For sure. Maybe I can share my screen for that. I
Sure.
do have a little bit of something here. Okay. So on a high level, I think, so I put that together just to kind of try and give a rough idea of what's going on in terms of architecture. So we're trying to achieve local recording, which is basically the idea of providing separate tracks. And we will talk a little bit more about that. We can deep dive into that. But all in all, what we're talking about is a WebRTC based solution that allows users across different regions to jump in a session and record that session. So the backbone of that, the core of that, is basically a WebRTC framework, and so usually there's a few solutions out there, there's a few tools out there, and we did our research. We kind of looked at different tooling, and we decided to first build an in-house solution to try and achieve that. And you're usually, what you're going to end up with is finding this in terms of like the concepts that need to be established here. We're talking about selecting forwarding unit, I believe it stands for, which is basically it's a controller that's responsible of kind of taking your stream and delivering it to the other peer. And it does that for every peer in a session. And that's one of the ways you can achieve that. And there's a lot of tools out there that do that. And so we chose one, and it's still open source. You can go ahead and implement that in your own way. You can deploy that. And so we deployed it. We took a lot of lessons out of it. It solves the problem, yes, but later we decided, well, there's a lot of effort here in trying to maintain and operate all of that thing. We can just use their cloud offering, and so that's the path we kind of took further down the road. However, on top of that, it's trying to achieve the idea of local recording. We do have sort of a parallel pipeline here that runs to be able to deliver this content on cloud storage. And Of course, there's a few challenges that we had to tackle here, um, managing those separate uploads they're happening simultaneously with your WebRTC feeds and communication channels. And of course, you need to think about what happens if there's some interruptions, and how do you recover from something that can go wrong there. And so this is kind of like what our pipeline looks like generically. People can connect, and this is through WebRTC, of course. They can start recording a session, and they can produce this content that gets delivered to cloud storage. And I will explain a bit more about that. And we do some transcoding and transcribing, as I mentioned earlier, for post. And we, of course, maintain some state and metadata that is responsible for kind of updating the UI and all of that. So a few other things that were probably worth noting here is, okay, well, that's straightforward in terms of looking at it as a few steps that you have to do, but how do you do that at scale is the challenge, really.
Right.
And so we looked at, of course, cloud solutions and offerings. We went with a major cloud provider out there, and we looked at how can we best utilize some bespoke solutions that exist within a cloud architecture, let's say, and not have to build it from the ground up ourselves. But at the same time, we did have to build quite a few of in-house solutions to be able to support this whole workflow. And we're still very early on. So that's, I hope I'm kind of giving a picture of what's going on here. So yeah, we talked a bit about kind of what this flow may look like, architecture, just high level, and of course we can deep dive into that a bit more. And I guess just maybe it's worth kind of mentioning at this point. We talk quite a bit about local recording. So I thought maybe putting just a couple of words here in terms of explaining what local recording is really. So the way I perceive it personally is the process of, because sometimes it can be confused and misused as a term, I think, out there. And so it took me a while to understand actually what it is. I believe it's the process of recording in a browser environment and syncing with cloud storage eventually. Because at the end of the day, your content is still going to be on the cloud. It's still going to be something that you're going to have access to. You're going to be able to go back and look at and start some post workflows. So it's still being delivered somehow. It's just that it happens as a secondary, let's say, pipeline or goal within your workflow. The question is why? Why do local recording? For two things. Because we want to maintain high quality separate tracks, and we want to capture HD video and audio even when there's network hiccups. So if there's a glitch on your Wi-Fi, if something goes wrong, your content is being delivered with no problems whatsoever. Like it's being delivered without any glitches within that. While if you take the raw WebRTC feed and you record that, of course you can do that server side, and you can try and achieve higher bit rates and higher qualities. That's fine. But you're still going to have this problem of like, what happens if? So
Right.
that's the reason. Obviously, it does come with a lot of its own challenges. So it's a bit of how do you say it? We say in Greek, "dikopo macheri," which means a two-sided knife.
Ah, yes. Yeah. A double-edged
So,
blade.
oh yeah, exactly.
Yeah.
Yeah. So that's it. Of course, yeah. If you have any questions, I'm happy to take you back and forth and wherever you'd like to lead this conversation to.
Yeah. Let's talk some more about the recording challenges and kind of the decisions that you made around that, because this is a key area where the use case that you're building for is really different, right? I mean, I think in any sort of WebRTC based application, you need to know what is the use case that you're building for, because that affects which media servers you're going to choose, how you're going to build your application, how you're going to architect your infrastructure, what you need to think about scaling, et cetera, right? And I think in our work at WebRTC.Ventures, when we're talking with one of our client with a a new client for us, one of the questions we always ask early on is, will you need recording in this solution? Because that is it can be big architectural decision. It can also be a big business decision, right? Because in some cases, when you add recording in a commercial CPaaS solution, it can dramatically increase the costs. And so, when we're talking with a client, we need to make sure that they understand that right away, right? And if those costs are, worth it to them, if they fit within their business model, fine, no problem, right? Because using that CPaaS solution may get them to market faster. On the other hand, if the nature of the business model that they have for this application doesn't support those cloud, commercial CPaaS recording costs, then you definitely need to look at an open source solution, building more of the recording pipeline yourself, et cetera. That can increase the amount of development time that it takes to build something, but
Of course,
your
yeah.
operational costs may be lower, right? So these sorts of decisions are super important. And in a podcasting scenario, obviously we care most about the quality of the recording, as you said. And so that's why you chose to go with local recordings versus cloud storage. Um, so yeah, talk a little bit more about how do you implement that? How much of that have you done kind of within an off the shelf or commercial media server versus how much of that pipeline did you have to build yourself?
For sure. So, I mean, obviously, we chose some of the tech and to support those WebRTC flows that we have. But building this local recording feature is kind of a separate track that there is quite a bit of effort that goes into that. There's no bespoke solutions, at least to my knowledge today, or from research that I've done a few months back, I guess, that may do that. However, I might be wrong on that. There may be solutions out there that actually perform that as a service kind of thing. So I'm just going to talk about our experience here. Um, uh, so basically, and I think we can share a little bit of a slide as well from what I tried to put together here. Um, I don't know if can you see that?
Yes.
Yeah. Okay, cool. So we've got browser platforms. Of course, we've got Chrome, Edge, we've got Safari, and a few others out there. Um, and all of them provide you with what we call some recording APIs. I believe it's the media recorder instance that you work with within a JavaScript within a browser environment. And so this allows you to capture the raw feed from the devices that a user has on their device, and then kind of decide what you want to do with that. Obviously, when you are within a WebRTC enabled experience, this already happens. If you think about it, this already is something that just happens under the hood of the either custom or bespoke solution that you may be using of their SDKs, and the feed is being sent. Uh, so I'm just going to try and find the right slide here. Oh, yeah, there you go. As we were looking at this kind of high-level architecture earlier, this is exactly what happens, right? So you've got different peers connected to a selective forwarding unit, and then those send their feeds and receive others' feeds. But then in parallel, you kind of have this feed that you're trying to sync your local recording. And then what this means is that within a browser environment, first we kind of looked at it in a very kind of silly way and tried to achieve this workflow um, as a quick POC, but quickly realized that actually it's not sufficient to just say, okay, well, you just have a run everything on the main thread in terms of within a JavaScript browser environment, and then this works out of the box. It's nothing like that. So we had a few challenges on the way, and this kind of led us into what you see right here, which is looking at this, taking the output out of this media recorder instance, while at the same time, of course, there's a bunch of other things happening on the UI, rendering, the WebRTC working at the same time, kind of storing some blobs out of and chunks out of the output of the media recorder within a database engine, and that is something, of course, that is provided within a web, I guess, environment. You've got the IndexedDB, and this is something that can help you because you have access from the main thread and from web workers, and I'm going to touch a little bit on that as well. And so what this allowed us to do is leave the main thread as I guess free of workload as possible, and kind of focus on storing, outputting those chunks into IndexedDB, and then you've got your web worker, which is responsible of taking those chunks and syncing them with cloud storage. And all of that happens, of course, via a network layer that exists within the browser and your OS. And then eventually this kind of ends up in cloud storage. Now that's high level of what's going on. And of course, you've got a few challenges there. So it may seem that this is something that works out of the box. I see some comments here.
Oh yeah. So yeah, sorry, I didn't mean to interrupt you, but we've got a viewer question here that is relevant. So Justin asks if you can talk any more about the SFU that you chose specifically for Chord, and kind of as you were starting to just talk about a little bit of how you get access to those recording tracks. For whatever SFU you chose, do their client libraries help with getting the tracks for recording?
Do their client libraries help with getting the tracks for recording? Yes, the answer is yes to that. And there is a lot of technologies out there and platforms that achieve something like that. We use LiveKit, and there's a few others out there. So there is Agora, I believe. There is Vonage, if I'm not mistaken. There
Correct.
is a few others. I'm pretty sure there's quite a few these days. And so all of those allow you and give you the SDKs that you can work with that stuff, and you can do egress, you can do recording just out of the box with their usually with their platforms and infrastructure. However, just a I guess kind of step back here into where are we different is that within the idea that we do local recording, so we kind of ditch this idea of working with those kind of workflows, egress workflows from those platforms, and we focus on kind of building that in our own way. So I hope I'm trying to answer the question here. But yeah, there's specifically in the provider that we used, they do utilize, I believe, an SFU in a similar kind of fashion. But all of that, unless you build it in as an in-house, unless you build it on your own, you choose a provider, and then you go and build it within a cloud provider on your own, set up those instances, those VMs yourself, set up those databases that you may need to. All of that is abstracted away from you if you use their cloud offerings, of course. And so this is pretty much the direction that we're in as well.
Excellent. Yeah, and as you talked about the different cloud providers and or the CPaaS APIs and WebRTC abstraction layers essentially do offer a variety of different ways of doing the recording. That's another important thing for anyone watching this, considering building recording into their application, is looking at not just the costs that may be associated with those, as I mentioned earlier, but also how they give you access to the recordings. So, Michalis, I think you mentioned, specifically that when you're doing recording for a podcast use case, you want to make sure that you've got separate recordings for each speaker, right? And some providers only give you a composite recording of the entire meeting, right?
Yeah, some of them, I don't know about the rest, but I can tell you about LiveKit. They give you definitely separate egresses and separate and composites. So you have flexibility there.
Yeah.
But at the end of the day, is what you're really trying to achieve, as you said. How does that, how do you want to utilize at the end of the day that content, and what exactly are you looking to get out of it?
Exactly. Yeah, exactly. And so making sure that, that's a lot of times in the meeting tools, if you're trying to record your podcast in a standard meeting tool, it's just going to give you a composite recording of the meeting, which is not what you want in that case. And so, yeah, using something a little more custom to the use case or lower level is important for that. So excellent. A question I have for you around on the recording side. So you talked about with having a hiccup in the network, right? That can affect how the recording is being uploaded, or maybe you have an abrupt end to the session prior to recording completely upload. So have you had to deal with that? And, do you implement like a re-upload, a complete upload kind of page? How does someone handle that if the session is interrupted?
It's you're totally right. Yeah, I mean, you will probably face those challenges. It's what comes almost naturally after choosing to kind of have those two pipelines running at the same time. On one hand, you've got your WebRTC feeds, and then on the other, which you can of course, as um, uh, I believe we were trying to reply to Justin's comment earlier. We talked about you can achieve via um, just doing recording on the server. Um, but then if you take this alternative path, you do have to go through and solve some of the problems that you're going to generate.
Right.
And what I mean by that is, now all of a sudden what you do is you utilize quite a bit more bandwidth of your connection, because what you're trying to achieve is you're delivering content in terms of live feeds, and then at the same time you're delivering content eventually that is of higher bitrate, higher, let's say, quality. And of course, uh, you have to think about what happens if a few things can go a little bit south there. And as they did for us, as some of our users started reporting some issues, we do have quite a few users at the moment in terms of we're still very early on, by the way. We have a few beta beta users to the numbers of hundreds. So we're quite early in this journey, and we have a lot to learn still. But yeah, a few of our users were like, "Well, everything is so laggy. Everything is so like not working. What is going on?" And so we looked at it. We couldn't figure it out at first. Then we took a closer look, and we're like, wait a minute. So if you can, I have a slide actually that I wanted to show here at
Sure.
this point. So you'd think that, well, not everyone has, a good kind of upstream when it comes to your broadband. Specifically, I believe within the 50s and 60 megabits. I know in the States as well, there may be within that kind of similar range. But we've had some users from Southern Europe that, some of those connections, they may have an upstream of less than 10 megabits.
Right.
And that's really a problem. So what happens then? And then, not to mention, of course, that we're obviously a lot of the times looking at a setup, at a home setup or studio setup that you may be sharing a Wi-Fi connection. Although it depends, some people may be wired, maybe more on the um, trying to get as much as possible out of their connections. But that's not usually the case.
Right.
I can tell you that. And so take that into account. The fact that you're running probably a bunch of processes on your device. It's not just the browser. It's not just a product like Chord that you may be running, and all of those contribute to sort of a congestion that of traffic that takes place eventually within different places of this whole flow, either within the browser, OS, or your router's internal buffers, let's say. And so really, it kind of boils down to those issues of what we were experiencing. If I take a step back here, first of all, I guess we touched a bit about congestion and what does that mean exactly. Congestion is really a term and congestion control that is closely related with the quality of service, I believe, when it comes to WebRTC and live feeds and all of that. And so I guess it's kind of having to understand that, there is, at the end of the day, some packets that are being delivered and packets that are being received, right? That's how kind of network basics are being done here. And then what we're doing on top of it is we're saying, okay, well, we're running a separate workflow on the side that we're delivering our local recordings. We're syncing these to with the cloud, and we're doing it while a WebRTC is in session. And so the two are a bit overwhelming at the same time, and they're overwhelming the network. And this is where the problems started. And so what we're really talking about here, I guess, is on one hand, looking at WebRTC, you've got your UDP packets being sent via your network there, and then on the other hand, we're capturing content from media recorder, and we're delivering that in a sense of HTTP over TCP, of course. Content. And so the two actually, we find out, know nothing about each other. So within a browser environment, there's no such thing as prioritization between WebRTC and HTTP. So how can I say, okay, well, give priority to the WebRTC because that's what's live. That's how I am able to communicate with someone. And, my HTTP requests are kind of secondary. So that's a challenge. It doesn't exist today. It doesn't. There's no such thing that you can say prioritize WebRTC over HTTP within a web environment. And so this is really where you start to scratch your head, and you're like, well, how do I go about that now? I think given knowing that we cannot approach this problem in a sense like that of prioritization. I believe there is the concept of prioritization exists within WebRTC streams and HTTP requests. You can have priorities, however, the two are completely independent. And so I can prioritize HTTP requests amongst HTTP requests, and I can prioritize WebRTC streams and tracks with other tracks, but I cannot mix and match here, is what I'm trying to say.
Right.
And so that was another side problem there. And I guess it all kind of gets down to really having to understand that really the problem that we're facing has to do with filling up buffers faster that we're emptying them. And I believe this is commonly known as the buffer bloat problem. Of course, you may ask what sort of buffers, because there may be buffers within a browser engine, there may be buffers within an OS network level and layers, and there may be buffers within, or not may, for sure there will be buffers within your router and devices. And I think that the answer is a little tricky to get it right here. You don't really know unless you experiment and isolate all of those instances individually and find out what exactly happens. And really, this is what we did. We got everything from trying to tools that allows us to limit uplinks to and upload speeds in terms of on the OS level, on the browser level, on the router level, to try and explore exactly what is going on. And a lot of the times we're not able to reproduce that because obviously maybe some of our users were on the lows in terms of upload speeds, but we were pretty good. So with the help of a lot of those tools, we tried to isolate it exactly, and we did replicate it. And we found that, indeed, there's quite a few problems around that we need to solve. And so that was a whole challenge. And so you try and think, okay, well, how do I solve that actually now? So there's no way we can define different priorities here. So what do I do? So you think, okay, well, if we take this example, which I found online, of this picture trying to describe what buffer bloats are, you've got your data flowing through your through kind of a pipe and filling in a bucket that has a little something at the end that it gets threw out in the wild, let's say. And then what you're really trying to do is say, okay, well, the flow here is quite high. So what am I going to do? I'm going to limit the flow, right? Well, that's not always the case, because let's say you had what do you call that? This switch that you have there, a pipe switch, that you're able to control
Faucet.
this.
Faucet.
A faucet.
Yeah. Opening the faucet or the spigot.
Yes.
Yeah.
So let's try and imagine it in such way. Let's think that you have one of those things there that you're able to control the flow. It does sound a little counterintuitive, doesn't it? Like
Mhm.
wanting to limit your speed, but why do that? But in reality, this is one of the solutions that you may be able to bring around such a problem. It would work, but there's quite a few things that you have to look at in terms of the overall uh, kind of problem statement here. It's not just that. Being able to control the flow is one thing. Looking at your packet sizes, looking at your chunk sizes, all of that play a role here in terms of how you deliver this content. And there are some limitations within, unfortunately, a web-based kind of HTTP level spec, let's say. But there is ways to go around them.
Yeah, I really liked in the article that you wrote on buffer bloat, which we'll include a link to in the show notes on this on our site at WebRTC.Ventures for sure, for those who haven't seen it, but you can find it on LinkedIn. There was a quote in there where you talked about how these sort of issues create user experience issues, but they can be hard to debug. So the buffer bloat quote is one of those hidden culprits that can make an otherwise well-functioning WebRTC app feel sluggish, unresponsive, or outright broken, right? And the fact that, like you said, there's different buffers at play here, can make it hard to debug, right? So, but when you're getting those kind of comments from users that things are lagging, and you have a local recording perhaps competing with the live stream, these are the sorts of things to look at, right? So it's a
Exactly.
it's a tricky problem to tackle.
It is. It's a challenge. Yeah, it's a challenge.
So what's your kind of general impression then of how congestion control is handled in WebRTC, or what would you recommend to other developers facing this? You talked about like the
I think generally
HTTP
speaking,
traffic and WebRTC balance, right?
yeah, from our experience, if you're only dealing with WebRTC workflows, I think that there's a lot of providers, as we discussed out there, that can give you this functionality, and you won't usually face any problems as long as you build a flow and your front end is kind of bug free and you're utilizing your SDKs in the right way, of course.
Right.
The problem starts, I think, when you start mixing up things like uploads, where in any kind of app experience, you may have something like that. Like, let's say right here, we're on a live stream right here. Let's say I want to send something to you, and we're going to do that via an upload that I'm going to drop something like a file.
Right.
If it's a few megabytes, and you kind of have an app experience similar to that, where a user is trying to kind of upload things within a WebRTC enabled app, this is when problems start. And we've seen that.
Right. Yeah, absolutely. Yeah. So we're starting to run out of time here, unfortunately. So I want to make sure that, are there other aspects around congestion control specifically or scaling in general that you want to make sure that, you
Um,
share with our viewers?
I mean, obviously, and I'm pretty sure maybe our viewers would know that there's a few tools out there that you can kind of observe what's going on when it comes to having to debug a lot of that stuff. I believe in Chrome you've got your WebRTC internals, if I'm not mistaken, that you can just quickly hop onto. There's a bunch of graphs down there that you can look at and identify what's going on. From a general availability, scalability point of view, this is really up to choices when it comes to, I guess, deploying a solution like that. Are you going to do it yourself? Are you going to do it deploy it yourself within a cloud provider? Are you going to choose this let's say backbone for your WebRTC as a cloud offering as it is just out of the box? All of those play a big role as to the overall stability of what you're going to do. Obviously, if you build something yourself, there's a learning curve. There's a lot of things that needs to be understood there. You may get it wrong at first, so stability may not always be something like you have to really yeah, it depends on what you are trying to build at the end of the day. Of course, within an app experience, so we not only do live communication and recording, we have a lot of that post workflows as well. I could talk a bit about that in terms of
Sure.
how we're tackling some of those problems, if this is something that we feel sorry, it's right here. But yeah.
Yeah. That's I'll make one comment, and then let's talk a little bit about the post workflow as we close up. But you mentioned like WebRTC internals, great tool at the developers' hands to kind of debug these sorts of things, and also brings up the importance, I think, when you're dealing with issues like this with beta users, of building in logging observability into the application, because it is going to vary with individual sessions, right? And so, ideally, when a specific user reports they had problems, you're able to go and you've logged some of those stats about packet loss and jitter and things like that that you can take
Yeah,
a look at, so you can compare to other sessions, right?
and I'm sorry to interrupt you, Aaron. I would
Oh,
also add the idea of trying to um, create a virtual sort of space of how in a real world scenario, as we've seen, for example, not everyone has a 20, 30, 50, 100 megabit upload speed. Not everyone
right.
has that.
Right.
So people need to realize that it's not always the case. Don't take those assumptions for granted that everything works on the internet. It doesn't, because there's users that will have less than 10 megabits uploads. And what are you
Right.
going to do next? Then you can't offer a high bitrate, high. So what I would suggest is kind of try and test that as a scenario,
Mhm.
and not only on a browser level. Try and put some throttle your connections at a router level, at a device level, OS level, and then you're going to see actually what happens in a real world experience.
Yeah. Great point to make. For sure. I mean, take it, most teams these days have remote team members. Take advantage of that, get people in different countries, different locations on different, networks to test it and get some real world data there, as well as doing things like throttling your connections to make sure that you're also observing it under specific constrained situations as well. So yeah, great tips, Michalis. Appreciate it. So yeah, as we close up, then we've talked a lot about getting the quality of these recordings together, the importance of that, obviously, in a podcasting use case. So let's wrap with telling us a little bit about kind of the post-production workflow and what you might what you can do with those.
For sure. So yeah, so one of our, I guess, main workflows is being able to be within a live session, live call, record that session, and then later we take that content, and the idea is that we want to build, a set of features in the future that will allow, of course, creators out there to take the most out of their content and repurpose it, edit it, and do lots of different things. And so all of that is serious work, and we've already started building a lot of that, a lot of those workflows, which practically involve kind of taking that content that is being delivered to cloud storage, encoding it, transcoding it, and doing things like transcripts and transcription, of course, because this opens up the opportunity for a lot more workflows further down the line for editing specifically. And so this is where pretty much we are. I'm happy to share with you kind of a high-level architecture as well here, if that's something that we feel may
Sure.
interest. Yeah. Okay. So I've had another slide which I've kind of left back here. So this is kind of a high level of what's going on under the hood. What you're effectively trying to achieve here is, after the delivery of your content, you're trying to standardize a lot of those formats, and so you're trying to create audio-only versions, MP4 versions that are playable across many devices. You're trying to do transcripts. You're trying to do audio analysis. There's a lot of things that are going on here, and so we do have sort of a pipeline for that reason specifically through APIs. All of those recording jobs are being once they're stopped, we get these notifications. We deliver messages within a queuing system, of course, and we kind of process those as separate tasks, let's say here, which is what would allow you to kind of scale that. So that's the idea. I mean, at the core of it, obviously, we run workflows with FFmpeg and other tooling and other CLIs and a lot of that stuff. But the kind of high level is that.
Excellent. Thank you for sharing that with us. And yeah, so there's a lot of complexity you've already tackled in building Chord, and lots more to come in helping your users with podcasting. And I appreciate the transparency and your willingness to kind of share with our viewers kind of some of the lessons that you've learned in your own journey on this. So thank you very much for that, Michalis. Appreciate
Of
it.
course.
Do you have any closing remarks, and how can our viewers learn more about Chord FM?
So yeah, we're Chord. You can find us on chord.fm. And yeah, you can sign up for free. It's completely free at this point. And yeah, we have plans for building quite a few, awesome stuff in the future. So yeah.
Excellent.
We're trying to be
Excellent.
on socials as well. We're trying to make an effort there as well. We're not, that big. We're very small, so you can find us on Instagram and Facebook. We're trying to kind of expand those channels as well.
Excellent. Thank you so much, Michalis. And so definitely encourage our viewers to check out Chord FM and check them out on socials and learn more. And look forward to speaking with you again and hearing more about kind of the next phase of your journey in building this. So thanks again for joining me today, Michalis.
Thank you, Aaron. Of course, if anything, our roads cross again in terms of any of those challenges or interests in the future. Happy to jump in another call and kind of talk. Thank you for the opportunity. Thank you for the opportunity, and yeah, for having me here today.
My pleasure. Thank you so much. All right. And so now we will remember to stick around. I'll have Sahi joining me for an industry analysis segment in just a moment, where we'll talk about the next generation of communications developers. But first, let me remind you that this video will be available on the WebRTC.Ventures YouTube channel, as well as on our blog at WebRTC.Ventures. And our next episode of WebRTC Live will be Wednesday, May 21st, with Professor Ali C. Began talking about media over quick and WebRTC. So that's going to be a really interesting conversation as well. Encourage you to check that out. And yeah, so to find out more about our upcoming episodes, Follow us on social media at WebRTC.Ventures on Twitch, LinkedIn, YouTube, and join our email list at WebRTC.Ventures. Thanks everyone for joining us today for another episode of WebRTC Live. Let's make it live. Thanks for joining me today, Sahi. We're going to talk about a little different topic than usual today. You've been mentoring some local youth on software development. My understanding is you're even working in some real-time application development into that. Tell us about it.
Yep. Yes. So there is this project in Israel called Magshimim Cyber, which goes and finds school kids in high school in Israel, but not in the center of the country, not in Tel Aviv. So not in the areas where you'll have all of the high-tech scene and the capabilities are just not there. And what they do, they start teaching them computer science in really small groups, like 10 kids or less, in classes around the country. And they do that from grade, I think, 9 or 10 until the 12th grade. And in the 12th grade, they need to pick a project related to communications in some way, and then go and develop that project. There are, I think, around 200 groups, something like that. Now, a group is 2 kids building a project.
Okay.
And when they get to that point, they assign to them mentors. Now, here it becomes interesting. The mentors are from the industry, and they just do it by volunteering. I was a bit bored half a year ago and didn't know what I want to do. And a friend of mine suggested go do that. So I did. I looked at the list of projects. Around 30 or 40 of them were either BitTorrent-like projects or TeamViewer or remote control of machines. So it was all like, well, that's WebRTC, that's WebRTC, that's WebRTC. So I said, I'll try that. It sounds interesting. I wrote myself all over there, which is not what you should do. I was new to that. And I ended up having 4 teams. I understood that only on the last week that I had 4 and not 3, because it was just so jumbled up. It was interesting and it was fun as hell. I'm definitely going to do it next year as well.
That's really cool. And so you said it has a communications focus specifically in this, or
Yes.
just the projects you picked did?
No, it's either like you need to build SSH, or just things that revolve around communication technologies. And then they have things that look like WebRTC.
Yeah.
And the kids need to go research it, figure out what they want to build on their own, build the whole architecture and technology in place, and do it in 5 sprints of 3 weeks each, which is impossible. And they need to write stuff, not only use third parties and cobble them up.
Yeah.
So if I'd come and say, well, just go use Jitsi or use Janus or use MediaSoup, or it would be, no, we can't do that. Or use the browser. Now you need to explain why they're actually writing stuff on the server and why it makes sense and why it's still a good project. So it was challenging in a lot of many ways. One of them was that you can't really do whatever you want. They need to learn from that how to develop stuff. Now I had 4 different groups. 2 groups, 3 groups developed with C++. 1 group used Python. Why? Just because they could use whatever they want. They're given like, do whatever you want. So it's really interesting. There was a group that started and said, well, we want to build BitTorrent. So I said, okay, that's nice. And then we started working on it. And they ended up taking libnice, like the C library that implements the ICE protocol, and then connecting it to their own implementation of a protocol that does BitTorrent, and building the whole thing around that. And then running, to show it and simulate it this week, they had 20 Docker machines running on AWS, showing in front of a machine that does all of the management of this, and running out of the laptops in the class through hotspots, and it was really, really fun.
I was going to ask you why C++, but if they're doing that low level with ICE protocol, now that makes sense. That's pretty wild.
Yes, and then there is another group comes in, and they decided that they want to build, what was it? Remote control with C++. But then you need UI. So they ended up using Qt and just,
Wow.
it was horrible. It was great. The project worked. They did the screen sharing. It was, and they didn't use WebRTC at the end. They used something called eNet, and then on top of that does reliability over UDP, and send the data through that to the other side. And they use the H.264 encoder using GStreamer or FFmpeg, one of these two. So it was really fun seeing. Then the third group decided they want to build TeamViewer, and they used Python.
Okay.
And they decided to use Python for the protocol and the network, not for the server. I told them, look, use the browser, and then we'll build something around the server that is signaling, and you can say that it worked well. No, they wanted to use Python. But then they came to this crazy idea of, well, we're going to use WebRTC, which is Python for WebRTC. And in order to have the GUI for that and the encoding, they use the browser. So they took a browser, they made it run the bindings in front of their Python code so they can run stuff through there. So the whole UI was HTML based. Then the browser did the screen grabbing and got the audio with get user media. Then it did the encoding itself, and they passed the frames in JSON of base 64 of the encoded data to Python, and they did that through the data channel in WebRTC and got 5-10 frames per second, but it worked.
Yeah.
And it was amazing just seeing these things and how they build these things and how it worked. It was really, really fun.
That's really fantastic. And I love that you're doing this. And I love the focus of the group too. Seems to me like among the array of services that you offer in the WebRTC industry, so you need to do some job placement and recruiting services, because you're training the next generation of half the people watching this probably are going to need to hire these people in a few years.
Yes, I thought about it. First of all, I am helping a customer now actually build his team in the recruitment phase and doing the interviews, the job interviews. But here, I thought about that. All of these kids that I were with this week, I would gladly go and hire the moment that they go into the industry.
Yeah.
It's fun because you take 17-year-old kids that deal with doing a driver's license, they are doing their final exams. In Israel, it's mostly in 12th grade. They need to do all of their interviews for the army on this time. And then there is a psychometric test, which is like the GMA test for going to university. Some of them do it at that point in time, even though they might go to university only 3 years later after the army. And then they deal with, school and life and the things that they have to do. One of the girls there in my group was actually, she's learning theater. She's not even doing anything scientific at school. And yet she just does computer science.
Yeah.
Then there's this guy that does robotics in parallel to this. And each one thing that they do takes a whole lot of time. And then they have this on top of it. And you talk to the people that are the ones that teaching them to code, and they go like, well, that's what we expect of them. Whatever they would learn at school for a full year in computer science, they learn with us in 2 weeks' time.
Yeah.
And that's it. And it's just crazy. And it works somehow. I don't know.
Oh, this is really cool. And it gives me some hope for like the next future, the next generation of engineers in the industry, because, I feel like one of the, when people talk about like AI development tooling, one of the lines of, criticism or hype, however you want to look at it, I suppose, is that AI tooling eliminates the need for junior engineers, or how are junior engineers going to get the training, the mentoring from others to kind of become a senior engineer eventually. And so I love that, that you're doing this and that this sort of group exists, because this is a way to get that. And the fact that they're not allowed to use, off the shelf components or any of the media servers you might normally recommend, they're obviously getting to really learn a lot of the really important fundamentals.
For me, it was really, really fun. First of all, being with kids, you become I just went back to being a kid on my own, doing this in the places that really need that. Not, it's not. I'm not doing it in Tel Aviv. In Tel Aviv, they're like, you can get this training everywhere in courses and stuff. You can't do it if you live in the north of Israel.
Mhm.
And then you start these discussions with the kids, and you tell them, you put on my put on my calendar an invite. They don't understand what you want from them, but they know how to code. It's like, it doesn't, or they won't send me a WhatsApp message because it's too late in the evening. It's 10 p.m. And I'm like, but what's the problem? It's like, they treat me as a grown-up, or it's so stupid. So it was really fun. I'm definitely going to do it next year. I'm not sure if I'll do it for 2 groups or 4.
Right.
I was driving this past week. I drove all of Israel to the north and to the south, 2-3 hours in each direction in my car, just in order to be with them for the half hour that they are going to show this to the other kids in their class. So me and 6 or 8 kids, and then went home happy after that.
Right. That's super cool. Well, that's great. I can see you've drawn a lot of energy from it, and that's one of the great benefits. Mentoring is not just about the mentee, but good for the mentor as well too. So
it's almost the opposite. It's like they're doing me a favor for letting me being with them. That's the way I feel in that relationship, in a way.
Yeah, that's really cool. Well, thank you for sharing that story with us, Sahi. I appreciate it. Anything else you want to add today or about that experience?
Going to Japan for 2 weeks. Probably once this gets published, I'll be back.
Yeah.
With the family. So a vacation.
Enjoy. Well deserved, no doubt. All right. Well, thanks for sharing your insights with us today, as always, Sahi. And for those of you watching, to learn more about Sahi's work, you can check him out at bloggeek.me. To learn more about future episodes of WebRTC Live, check us out at WebRTC.ventures. Thanks, Sahi.
Thanks, Aaron.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.